Welcome back to Vectoring AI, where we trace the journey of artificial intelligence across the decades. In our last episode, we explored the 1990s, a period when AI became more statistical, more data-driven, and began to quietly power applications like speech recognition and email filtering. The 2000s built directly on those foundations, but something new and transformative arrived. Vast amounts of data, powerful new hardware, and the first true breakthroughs in deep learning. This was the decade when AI began shifting from the laboratory to the center of the digital economy.
The first key factor was the explosion of digital data. The World Wide Web, social media, and digital sensors generated information on a scale never before imagined. For the first time, researchers had access to millions of examples, orders of magnitude more than the datasets of the 1980s and 90s. This abundance of data was essential because modern AI systems require examples to learn. By the mid-2000s, large collections of speech, images, and text had become available, enabling more ambitious machine learning research.
The second enabling factor was hardware. Graphics processing units, or GPUs, were originally designed to accelerate video games, but researchers realized that the same chips could be repurposed for AI. GPUs could run thousands of operations in parallel, making them ideal for training large-scale neural networks. This discovery transformed what was computationally possible and became one of the defining enablers of deep learning.
Datasets and hardware came together in a landmark project, ImageNet. Launched in 2006 by Fei Li, ImageNet eventually collected 14 million labeled images, carefully categorized to support computer vision research. For the first time, researchers could train algorithms on data vast enough to capture the complexity of real-world objects. Around the same time, massive audio datasets were built for speech recognition, providing thousands of hours of recordings. These resources, combined with GPUs, set the stage for deep learning to take off.
The breakthroughs came quickly. In 2006, Geoffrey Hinton and Ruslan Salahudinov introduced deep belief networks. They used a technique called greedy layer-wise pre-training, which overcame some of the long-standing difficulties in training deep networks. Their models performed impressively on tasks like recognizing handwritten digits, showing that deeper neural architectures could finally be practical. By 2009 and 2010, deep supervised learning trained with backpropagation on GPUs began winning competitions. A deep neural network achieved top accuracy in the German traffic sign recognition contest, foreshadowing the landmark success of AlexNet in 2012.
Reinforcement learning research also advanced in this decade, laying the groundwork for breakthroughs that would emerge a few years later. While the dramatic results of combining reinforcement learning and deep learning came after 2010, the 2000s established much of the theoretical and experimental basis for that revolution.
Robotics and autonomous vehicles saw dramatic progress, largely through the DARPA Grand Challenges. In 2004, most teams failed to complete the desert navigation course, but by 2005, Stanford's vehicle, Stanley, successfully drove 132 miles across the Mojave Desert in under 7 hours, earning first place. 2 years later, in the 2007 Urban Challenge, Carnegie Mellon's Boss Chevy Tahoe navigated city traffic and intersections to win the prize. These contests proved that autonomous vehicles were not just science fiction, but a real technological possibility. In 2009, Google quietly launched its self-driving car project, hiring veterans of the DARPA challenges. This marked the beginning of the modern autonomous vehicle industry.
Meanwhile, consumer-facing AI was becoming part of everyday digital life. Gmail's spam filters relied on machine learning to protect inboxes. Recommender systems from Netflix and Amazon shaped what people watched and bought. Banks used AI for fraud detection. These systems worked quietly behind the scenes, but they showed that AI could deliver value at scale in the digital economy. By the end of the decade, research into voice interaction was gaining ground. Apple's Siri, announced in 2011, was born from work carried out during the late 2000s, signaling the rise of AI-powered assistants.
Looking back, the 2000s were a decade of convergence. The availability of big data, the rise of GPU acceleration, and the creation of scalable algorithms transformed AI's potential. Research breakthroughs like deep belief networks, competitions like the DARPA Grand Challenges, and the launch of massive datasets like ImageNet all pushed the field forward. In industry, AI was no longer a distant promise. It was filtering emails, recommending movies, stopping fraud, and beginning to drive cars.
This period set the stage for the dramatic advances of the 2010s. Deep learning, which had struggled for decades, was about to become the engine of modern AI.
In our next episode, we will step into the 2010s when deep learning exploded into the mainstream, AI surpassed humans in key benchmarks, and machine learning became central to business, science, and everyday life. Thanks for tuning in to Vectoring AI. If you enjoyed this episode, don't forget to like, subscribe, and share the channel. Stay with us as we continue exploring the unfolding journey of artificial intelligence.